I dabble in amateur geology a little bit here. I have a couple rocks here from West Virginia. Here you have quartzite. This is what Seneca rocks is made out of. It's like a marbleized sandstone. It's actually hardened so much, underheated, that it remelts and becomes like this glass, really. And it's so hard that it doesn't erode very much. This is red quartzite. This is it polished. So what you're looking at when you see Seneca rocks, it's a big, it's a set of fins that run down the mountains. And what you're looking at, you see this quartzite that is the only thing left standing because everything else around it has eroded. And I'm going to kind of explain to people what happened many, many years ago. You have two continental plates. It's the same mountain range. You get into the highlands, like the Bedford at Shawnee. You'll see the Allegheny Front, the Appalachian Mountains. So it's the same at Seneca. You have the Allegheny Front. The rock layers on the Allegheny Front go this way. Okay, so this other plate came underneath it, and you have a little bit of room here, and then you have a mountain with this big set of quartzite spines. Think about that. This is about 200 feet thick. Okay. And then you have another valley, and this massive mountain that comes up like this. Then it has like this thing, looks like a wave on it. It looks like this. And it's North Fork Mountain. And this is quartzite. And the rock layers are going here like this. Okay, so these two plates, when they actually collided, the one went underneath the other, and it pushed this up. And this actually went so much that it actually bent into a massive, massive mountain. They figure at one time was about 15,000 feet high. Okay, when you look at Seneca right now, it's about 1,000 feet. I believe North Fork Mountain is about 1,500 feet. So what you're looking at, it's really hard to understand. At one time, this was bigger than the Himalayas. And if you look at this rock layer and this rock layer, they're the same rock layer. At one time, it was a dome of quartzite that went like this. That was bent. With all these other rock layers that are gone. You had rock layers all over the place. They were all sand and things like this shell and this feldspar, which is like magnesium or I believe potassium feldspar. It makes up your dirt. So, you had all this fill in, all this eroded away, and the only thing that's left that didn't wear away are these quartzite spines. Now all this here fell into the valley, and it's probably deep down in here where they mine it. But at one time this would have looked essentially like this, like Mount Everest size, bigger, like that. And when you drive through it, you don't realize you're actually looking at just all that's left, these massive spines of quartzite are all that's left of this once ancient mountain, that the weight of it actually pressed the sandstone, which was a beach at one time. You can figure at one time this was a beach, and it got pushed over, the rock layers got pushed over, and all the sand on the beach twisted, and it went underneath. But as it did, the pressure of the overlying rock melted it down into this glass. It's very slippery to hike on. You can see now just how it sparkles. A little bit of history and geology there for you. And the whole mountain kind of resonates with this energy, as quartz does. All the particles, all the sandstone in it is perfectly aligned, even with this red quartzite. And you can see when I polished it, unlike sandstone, it doesn't have, you really can't see because there are no grains of sandstone in it. It's just like a piece of white glass. Fascinating history when you drive along and you see these outcroppings and you wonder how they got there and what you're looking at. Gives you a little bit of idea of the history of the geology of the place.